Hi folks, Vivek from ExamVictor.com. Another video in the foundation series in Quantitative Aptitude section. In this one I'd like to talk about properties of squares. As usual, if you have any feedback or comments, do send me an email at vivek@examvictor.com. Now you might be wondering, why is it so important to even know these properties of squares? And your question is honestly semi-valid. I would go ahead and say that there is not going to be ever a question that will depend on these specific knowledge points. If there is such a question, you should probably be able to solve it in the exam even without knowing these things. But these things are good to know. These points and the points in the following page are good to know because they have the potential of saving time. Alright, they're not just gimmicks. You know this at ExamVictor. I've said this repeatedly, that we don't believe in gimmicks. I don't believe in teaching you some tricks that might impress people but are actually of no use in the exam. I know many other coaching institutions do that. We don't do that here. So these are useful, but I'm going to go ahead and say with full honesty, if you want to skip this lesson, that can be done. You will still be able to solve all the questions, just that there might be a question or two here and there that you would not solve as fast as the guy who watches this video. Okay, having said that, the properties of squares that I do want to point out, there are probably more that are not relevant, but I've selected these because I've seen questions that could be solved easily if you knew these properties. Alright, first one, square of an even number is even. Quite obvious. Even into anything is even, so even into even itself is also going to be even. Similarly, square of odd number is odd, because when you multiply two odd numbers you get an odd number, so when you multiply an odd number with itself also you should get an odd number. Square of a negative and a positive number is positive. So actually this is not very well structured. What I mean to say is the square of a negative number is positive and the square of a positive number is also positive. Basically it's just -1 into -1 is actually equal to 1. So this is what we're using here. The square of the negative number is going to be positive. Alright. Then the square of any natural number will be of the format 3k or 3k plus 1. This is really interesting, and we don't need to bother about the proof of this because that is not relevant to us. You can look at the proof if you want later, but it's not really important. Just take an example, you'll see what I mean. Take 6 square, that is 36, right? 36 is in the format 3k. 3 into 12, 36. Look at 7 square. 7 square is 49. 49 is in this format, 3k plus 1, right? 3 into 16 is 48, plus 1 is 49. So the point is that any square of any natural number is going to be in this format 3k or 3k plus 1. Further, even squares will be of the format 4k also, and odd squares will be of the format 4k plus 1. Look at the same example. Even square, this is 6 square, 36. This is of the format 4k, right? 4 into 9, 36. Odd square, which is 7 square. 7 square is 49, and 49 is going to be 4 into 12 plus 1. So 48 plus 1, 49. It's a quirk. The proof is not very important. If you remember this, great. If you don't remember this, doesn't matter, because the question that requires you to solve this, there will be another way to solve it also. Okay. Another point, square of a natural number will only end in 0, 1, 4, 5, 6 or 9. It will never end in 2, 3, 7 or 8. Again, something if you don't know also you will get along with, but I've seen a question that actually used this specific knowledge, so it's good to know this. So this is just a quirk again, that squares of natural numbers, they're only and only going to end in 1, 4, 5, 6, 9 and 0. Okay, so since we're talking about last digits, the last digits of squares, so sometimes you see these questions about the last digit and the second last digit. There's actually some correspondence there. Okay, so on the previous page we saw that the square of a natural number will only end in these, right? 0, 1, 4, 5, 6, 9. Turns out that depending on what the last digit is, you can even imply the second last digit. Okay, let's take it one by one. So if the last digit is 0, then actually the second last digit also compulsorily has to be 0. If the last digit is 1, then the second last digit has to be divisible by 4. If the last digit is 4, then the second last has to be even. Last digit is 5, then the second last digit has to be 2. Okay, so the last two digits have to be 2, 5. Doesn't matter what all comes before that, but the last two digits have to be 2, 5. If the last digit is 6, the second last has to be odd. The last digit is 9, second last has to be divisible by 4. Let's take examples for each of these, okay? So example for this one. Last digit is 0, so let's take 10. 10 into 10, 10 square, that is 100. And 100 has the second last digit also is 0. This is fairly obvious, right? If the last digit is 0, that means it's a multiple of 10. And when you square 10, you get 100. So your square is going to have 0, 0 in it. So that's fine. If the last digit is 1, then the second last digit has to be divisible by 4. Let's take 11. 11 square is 121. The second last digit has to be divisible by 4. So actually you got 2 here, which is not a great example for this, but